Hear it. I'm also excited to see you all again. Dana, I saw your email with the one question about good practices around testing React components. So I was just modifying the slides now to add in a quick slide about that. But yeah, I can definitely show that. It's a good question. And if any of you have any other questions, comments, things you want to go over, please let me know. I'm happy to go over them at the end. I'll have until not five, until 4:45 today. So we can go a little over for me.
What time zone are you in, mate?
Oh my God, I forgot that's a thing. Eastern Standard Time. So it's 3:32 for me right now. I can go till 4:45. Let's present. Cool. So we're going over, I'm not enjoying PowerPoint. We're going over unit testing with Jest, wrong view. As with last time, this is going to be pretty code heavy, so I'm just going to keep the presentation available to see on this side and then show you my repo on the other side. Same intro as before in case you forgot who I am. I like cats. I work at Codecademy. I like things like justice, reform, and open source too. I'm from New York. Good stuff. All this stuff is on joshuakgoldberg.com. Link to the repository, link to the slides. So if you miss this, this is being recording, so you'll be able to find it there. Stuff we're talking about today, I want to go over the different types of testing. That's also something someone had asked. Specifically, what's a unit test, the thing we're mostly talking about? How does Jest work? What does it do for you? What does it give? The basics of running Jest matchers, which are the things that throw errors if your code sucks. I mean, code isn't working as expected, wink. Mocks, which are really useful functions that remember what they're called with. And then a couple of good ideas around testing AAA, or Arrange Active Cert, and TDD, test-driven development, which someone did ask about. These will all be in the slides. You don't have to memorize any of these acronyms. Most people, myself included, forget them half the time. Again, I'd recommend the concepts here are kind of the important thing. You can always look up and Google the syntax later. The Jest docs are actually really good, like shockingly good. So definitely don't worry too much about retaining too much of that information. I'm assuming by now, definitely all of you already had Git and Node and probably VS Code locally. And then there are slides in the notes, links in the notes for anyone who comes in with a fresh computer. The repo is Jest Testing Companion. I have it set up locally in my repos, and I'm going to open it in VS Code, code dot, which is one of my most common terminal commands. Should I slow down? Does anyone have any like prerequisite questions before I get started? Excuse me. Cool. So what's a unit test? What type of testing is this? To start with, I typically refer to the, excuse me, being three types of tests, unit, integration, and end-to-end. Different people have different opinions on what each of these are. You might talk to someone else who thinks integration and end-to-end are swapped, for example. Fine, whatever. This is just my personal nomenclature. They go from small scale to large scale. Unit test is a single piece of logic or a unit of code. Like you might write a function that says, is password length valid as its name? And then there might be two pieces of logic that run it. If the password's length is 6, it returns true. Otherwise, it returns false. So that's one piece of logic. It's not a bunch of different functions calling to each other or a bunch of, I keep forgetting to close a bunch of random components working together. It's one single thing. That's why we call it a unit. And we like unit tests because these let you test a single piece of your app individually. It lets you get directly at that one piece of logic, that one unit. Sound good so far? Out of curiosity, I know you've all written some amount of unit testing before. Is this kind of methodology something that you're familiar with or have looked at before? Shaky hands, shaking head nods, sounds good. Cool. Integration tests are when you test that a few things work together, not the entire app, like the entire product app that is, but maybe like a couple of services or a couple of functions work together well. Like when a user put request doesn't have as good of a password, your service might return 400. That's different from an end-to-end test, which would be like I type in a bad password in the forum and I get an error. This is like a specific subset of the app working together. So we're just going to talk about unit tests today. You can do unit integration and end-to-end in Jest, but Jest is most commonly used for unit because it's got really good setups for very small granular changes to your code. Yay. I also think unit tests are a particularly valuable thing because they're really, really good at catching edge cases. They don't do the system as a whole, they're very specific. So they're good for letting you test very individual specific pieces of your logic in your code. And because they're small and the fastest form of tests, because they test the fewest amount of things, people like them both as a form of documentation and as something to always include in your code. So one piece of advice I always give to people is if you're changing logic, you should probably write a unit test. Either the code was already tested and you'll have to create, add, remove, update, whatever existing tests, or the code wasn't tested before, in which case you'd be a great person for adding unit tests to it. And there's a whole field of study around how to add unit testing or improve unit testing on an existing project, which we won't get into now. There's strategies around that, but we'll talk a little bit about TDD later, which is a good strategy for making sure you're writing tests. So what do y'all think? Any questions or comments on unit tests so far? Cool. Moving on. What is Jest? So to start, I guess we can minimize the code stuff. Jest is three things. TypeScript was a couple. Jest is also multiple things. The first and most powerful, important one is the file runner, which reads files from disks, runs them, and reports results, and has a bunch of awesome options around it. So, dang it. Where's stupid Mac? Okay, so let's say I have my repo open here. I'll close the activity bar. And let's say I run Jest. Oops, I forgot to install it globally. While that's happening, I'll just do npm test to use this repo as local one. So Jest, let's just quit it right now. Jest has found all these different files, which all have .test.js, and realized that, oh, these are different test files I need to run. By default, Jest will run each of those test files in its own separate process, meaning it's a different node.exe that's running for each of them, which is actually really nice because in some code bases, people write to global variables a lot, and you don't want one piece of code, global variables, messing up another piece of code, tests, global variables. So by having a different node process for each thing, you get a really nice separation between all your unit tests. Yay, Jest. Now, if we keep running, we'll see from these tests, Jest has this like really snazzy terminal output that shows you like the expected time remaining. I have a bunch of intentional failures here. You can see that it reports, okay, so this file failed because this test, whatever, something was expected to be an array of size 4 and its actual length was 3, whatever. We'll look into those errors more soon. But one of the big key features that made Jest really popular is that its error messages are actually freaking awesome. And it shows you like the list of failed tests and like how many test suites failed and how many tests were in those suites, or each file is a suite. Cool. Any questions or comments so far? Cool. In each test file, let's look at, let's say greet.test.js. It provides a few descriptors, which we'll go into each in detail. It allows you to describe a group of tests, greet, and then within that group, you can describe a bunch of tests. You don't have to group your tests like this. You could keep them floating, but I like the groups because it helps keep them organized in the test output. This is saying that for the greet function, we have two tests. We test that it doesn't include a middle initial when not given a middle name, and it does include a middle initial when not given a middle name. Wait, that's wrong. Haha, typo. So, as alluded to but not spoken in a previous slide, a good test suite can actually act as really powerful documentation for your app. Without looking at this greet import, the source code for that, you can already tell that this greet function, when given Josh Goldberg, returns hello Josh Goldberg. But when there's also a middle name, it abbreviates the middle initial. And that's a surprisingly useful thing about unit tests. You might not experience it too much with projects that live only a few months. if you're the only developer. But if you're joining someone else's project, or if the project has like 20 developers on it, you want as much documentation as possible. And written documents, as I'm sure you've experienced, get out of date and old. But tests never lie to you. Cool. And lastly, we're going to also talk about these test utilities like expect, which make it a lot easier to write the tests. You don't have to use them. You could be like, if results not equal below Josh Goldberg. You could do that, but these expects are how Jest gets the really nice difference versus actual outputs into CLI. So if we were to run just greet after I make this change, the error that we get, let's make it fail intentionally. The error that we get is not as great. So definitely a big fan of using the built-in Jest assertions. Does that make sense so far? Any questions? Word. Let's not suck here. Cool. So we're not going to go too much into this, but just know that Jest is very configurable. This repo comes with a very simple Jest file, which adds a bunch of extensions to it. But you can change behaviors around how mocks, which are things we'll go over later, work. You can make it work with stuff like Babel and TypeScript, and you can modify what test file pattern to use to check and all this stuff. A lot of cool stuff there that we're not going to go into. But these are the docs if you want to get started on your own. You can also just copy and paste the files from this repo, LOL. I will note that if there is a Babel config, Jest will read it. So like you saw in Greek test.js, I am using the like fancy new modern import from syntax rather than the old style require syntax, which right now in Node you need Babel to compile to you. So behind the scenes, Jest will take in your code and run whatever transformer you're using, say Babel, in order to make it like a nice runnable piece of code. Cool. So yeah, more specifically, this is the formal definition, test descriptors. You can see the whole list of them at the Jest website. So if we go to Jest.io docs API, it's actually I can't stop talking about how good these docs are. There's a huge list of them. If you ever want to see all the options here, you can take a look at the docs. For example, this scribe can be nested, fun fact, binary string to number when whatever is true. There are other fancy things you can do with these, like tables, which are kind of cool. More on that later. So the expect takes in a value specifically and then returns a bunch of stuff. So let's say const matcher equals expect results. I installed in my package the @types/jest dependency, which if you remember from the TypeScript talk, even though I'm not using TypeScript, gives me really nice features in VS Code to look at all the things that can be returned from expect return value. So we can check all the stuff up in 3, 2, 1, to strict equal. And then they have nice docs there. So I definitely recommend installing at types/jest to take a look at these. Or if you want, look at, going back to the docs here. Where's my window? I closed it. The expect docs, which has the full list of the built-in stuff all over, which is pretty great. And yeah, you can read those at your own leisure if you're interested. They're quite expansive, excuse me. There are a few modifiers that you can use here if your tests aren't quite done. Let's just undo all this code. You can .skip on a group or describe, an it or describe, I should say, which means that it won't run this test. You can also do a .todo if you know you're going to write it soon but haven't gotten around to it, which can be useful. By the way, fun fact, if you right-click, copy relative path, and then paste that into the Jest command, that'll just run the test you're looking at, which is quite nifty, very useful. So yeah, here we see that it just tells us we've skipped this thing and then we've to-doed this other thing. So very useful if we're trying to, not break our code with tests that aren't working yet. Lastly, from the core stuff, test tables, which is something that I think a lot of people underutilize. By the way, have you all learned what a Fibonacci number is? Has that been part of the curriculum? Does anyone know what a Fibonacci number is? Cool. Cool. So just to recap, a Fibonacci number is so like shows up in all sorts of places in math, but Fibonacci of 0 is 0, Fibonacci of 1 is 1, and then Fibonacci of any other number is the sum of that number Fibonacci minus 1 plus the Fibonacci of that number minus 2. So you can implement it like this: Fibonacci of I minus 1 plus I minus 2, unless it's 1 or 2. Or 0 or 1, excuse me. Anyway, if you were to write like some math equation function that want to unit test it, you could write the same test over and over and over again with different inputs. Or you can use a table where we say for each of these pairs or each of these list of inputs, we have a test under that. And the test generator takes in this case, 2 inputs. Or like Fibonacci of 0 is 0, all the way up through Fibonacci of 7 is 13. Now I learned a while ago at strategy and teaching. I think it's not roll call, but like attention call or something like that, where you force some random person in the audience to say a thing and so that the class can continue. So what is Fibonacci of 8? Someone tell me. I see 2 people's mouths moving, but you're muted. Someone tell me. Fib of 8. What's 8 plus 13?
21.
21,
Yay!
yeah.
Woo! Thank you. Cool. Awesome. So let's say I screw it up and write 28 because I have a fool and can't hear. And then we do just Fibonacci. We see that it has generated all these tests for us, and then one of them is failing. Yay. So now if we fix this, oh, by the way, in -- watch mode, Jest will rerun whenever your file changes, which is absurdly useful. 21. Yay, it finished. It did the thing. Cool. So those are kind of the core Jest commands. Probably if you've written Jest before, you're familiar with most of those, but I think it's always helpful to go over the basics. Does anyone have any questions or comments so far?
I think this is kind of a extremely basic question, so sorry for anybody who knows this already, but so am I correct to say that like you would use describe if you are going to have like a bunch of its, and that you would use test if you just have one thing to test?
Oh, that's a good question. That's good feedback for me, actually. I forgot to go over the difference between those. So thank you. That's not a basic question at all. It's actually quite good. So you can do this. Let's go to Greek test. So you can do this, it, or you can do test. What's the difference between test and it? There is none. Why does it have 2 different things under the same name that do the exact thing? Great question. I don't know. My guess is that different people like writing tests in different ways. I'll cover this later, but in my opinion, your test should read like plain English or whatever language you're writing your code in. In this case, we say Greek does not, etc. when, etc. That's a nice sentence. It would be rather confusing to see someone write a test like it works, or even worse, grammatically incorrect, it work. Like what does this mean? What do you mean it works? When I'm looking at the Jest output, what does that give me? So some people write them in this way with the its, but sometimes it's hard to formulate an English sentence for a particular thing that would work with the it. So like sometimes it just looks better when you write test, like test edge case X. It really is a style preference thing though. Like I think it's important to get right because it makes your tests look more useful, but like if you get it wrong, they'll still work. Does that make sense and answer your question? Cool. What else do y'all want to ask before we move on to matchers? Awesome. Well, in that case, moving on. Matchers, which is what you get back from expect, as we went over in the docs file, there are a whole bunch of them. Just as an example, my 3 favorites that I find myself using a lot, which does change now and then, are to be, to equal, and to contain. Did you know there's an object.is method in Node that is basically the same thing, but is not quite the same as triple equal? Fun fact. It basically triple equals. So that's what 2b does by default. 2equal will do a recursive value check. Like it doesn't have to be the same object reference. So if you were to run, say, this code, let's just look at this 2equal test. Here's a good example, by the way, of when it kind of looks better to write test instead of it. And then you were to write 2b instead. Notice it's the same letters, A, B, C, D, E, F, G, H, I. I'll just make it simpler so it's easier to read. Let's say nothing. And then you do just matchers watch. Notice how it still fails even though it looks the same. It's because these are two different arrays. And it even gives us that nice little suggestion if it should pass with deep equality, check to be strict equal, which works. Strict equal is a little more restrictive than 2equal, as you might guess from the name. So, yay. But there are a whole bunch of these. And again, really, I would recommend after this going through that huge list in the doc site, because the better the error messages you get, the nicer. Like just looking at this error message here, this is a work of art. This gives you the list of things in the array and uses a red, green, minus, plus diff to show you where your array is off. That's awesome. That's so freaking useful for code. Highly recommend. I don't know, just by like nod / show of hands / exasperated sighs, who here has been in a case where you have a failing unit test and you can't figure out what's wrong? Has that happened to any of you yet? Yeah, my life daily. So highly recommend using the right matcher in the right situation. There are actually a whole bunch of matchers that don't come with Jest but are still useful. We saw in the Jest config file, I used Jest extended. This is an example of one of the many community added matchers. Jest core doesn't include everything, so they add them here first to see if people like them or like stuff that's a little too niche. So like if you're trying to assert for something and just you can't quite do it nicely with the core matchers, you might want to use something from the extended suite. I particularly like 2b array of size whatever, which is similar to the 2 have length matcher, but also asserts that it's an array, which I think to me this looks more reasonable and like more clear. I don't know. And then to end with is nice. There are also like date ones, like whatever this is. Expect due date to be before and like to be after, which is, I don't know how often you have to do date logic. Hopefully never, because it's the worst, but like that's kind of nice. Cool. Anyway, have any of you used like Jest DOM or any of the other Jest extensions yet? Well, you're gonna like this stuff. Moving on. Actually, before moving on, any questions, comments so far? Okie dokie. I will note every matcher can be prefixed with not. I don't know how many of you are fans of the original Borat movie, but there's this great scene. This code is black, not. But yeah, it does exactly what you'd expect it to. I don't know if I'm pressing the right file. Extended watch, where it gives you a nice error message if the thing is not the case. Expected value to not whatever it is, be an array of size. So that's nice and useful. That's part of the core docs for the expect. Yay. There are these, I only learned about them like a year after starting to use Jest, which upset me. There are value matchers, which allow you to specify in more or less detail what you want to be passed in or what you want something to equal. You can do expect.string containing to allow any string that contains some substring, or you can use a regular expression with string matching, which is kind of awesome. And then if you mess this up, just values watch, look at this one, you'll get a really nice error message there too, where it says like the string is this, but we wanted it to contain that, or we expected a string to contain I and we received hello. So that's nice. And then moving on, you can do this whole nesting situation with object containing, where you expect some objects to equal an object containing happy true. And then you can recursively include those. Let me get rid of the dot there. So like if you have this whole object structure where like this is supposed to be an object containing happy true in any string containing OSH, it'll give you the not the greatest error message, but at least some nice equality checking results for command line. Yay. So yeah, if you're looking for general matchers, if you don't want to test exactly what something is, or if you want to test like a recursive structure, this stuff can be pretty useful. Would recommend. Have any of you used snapshot testing before? I see one head yes and everyone else no. Awesome. So what happens if you want to test a really big object? Like, let's say you have this result object here, and you want to make sure that the result of an API is exactly this. You could do like expect results to equal first SpongeBob last. Like that's pain in the ass. I'm already bored writing it out. So what you can do is create these snapshots, just snapshots, where just will automatically make the string equivalent of that for you, like a file, or even writing it directly to your test, which is kind of wild, I think. So like in here, this first one, we expect that the result matches this thing here. And then if it ever gets updated, just test -u, or I think it's -update snapshots. Oh, no, -u it is. Oh no, I messed up my order. Just test snapshot -u, or snapshot is the name of the file. I guess it's just going to run all of them. That's weird. Fine, whatever. Anyway, here we go. We're just updated the snapshot to automatically match what this changed from. So that's pretty nice. And like, let's say the API returns a new field, and then you run just test update again, and it'll automatically update the snapshot file for you, which is pretty sweet. So instead of writing out explicitly in our own code, like by hand, all the fields that we expect to be on the thing, we can have just automatically create the snapshot of what it's supposed to look like. And then if we don't run with the -u or update commands, just will give us failure. Oh, it's because I'm running test. What am I doing that for? There we go. There we go. It'll give us a failure that like, hey, something, say we mess it up, something doesn't match the expected snapshot, and it'll give us like a nice diff on it. But here we go. It tells us that like in our code we had SpongeBob 2, but in the snapshot we had just SpongeBob. So yeah, you can put the snapshots in a file, or you could put them in your code, and it'll either way tell you that like, hey, your snapshot doesn't match up. Does that make sense and seem reasonable?
Is it the to match inline snapshot that's like creating the snapshot? Is that like the syntax that's doing it?
Yeah. So what Jest does when it sees to match inline snapshot is it'll modify your file for you. So like right now, it gave us this little ready true. And if we were to run just whatever the file name is, I'll just copy it explicitly to make it more clear, -u, and then like modify this in some way, let's remove it again, we'll see that Jest like hand edits our file for us to get rid of the outdated snapshot. So this is for if you have like a small object and you just like want to put it there and you don't want the overhead of another file. But if it's like huge, if it's like 3,000 lines or whatever, then it can be useful to put it in a separate file to keep things clean. Any other comments or questions on snapshots?
Yeah, I had a question on snapshots. I thought it was used for like for parent components to render some portion of the children component, right?
Yeah, that's a good use of them. Just has a whole guide on this actually, on like when to use snapshot testing versus visual regression testing. But yeah, we do this at Codecademy in a few places where we have a big parent component that renders a lot of child components for React, and we just want to make sure it all looks the same. Like on our checkout page, if we screw up the checkout page, we lose out on like tens of thousands of dollars. So we really don't want to make any changes to that accidentally. Or like the help and support pages, if people can't ask for help, they hate us. So yeah, like that's a really good way to make sure this is exactly what the component renders. And you can actually extend snapshots to use different like renderers for the output code. And popular React toolings do that, where they'll take in a React component and then use an extension to formulate that React component in like a nice JSON structure that goes in your snapshot. Cool stuff. Does that answer the question you meant to ask?
Yeah, it does. Thanks.
Any other questions or comments on this stuff? Cool. Now, question for you all. How many of you have used mocks, either with just.mock or just.fn in your Jest tests before? Yeah. One, not so many? Sweet. I think they're awesome. It's one of my favorite features. So let's say that you have a function and you want to make sure it was called in a certain way. Let's say that you have an API that does a bunch of work and then calls a function with the result of that work. Well, how do you make sure that the function was called with the right thing? If you were to manually implement a mock, you might do like, I don't know, like let my results, then like let my function equals results. My result equals result, and then like you might do like call API with my function, and then expect my results to be whatever. That's a pain in the butt to write this out. And then what if you want to make sure that like the function was called with a certain thing, or was not called at all? Or like, let's say you want to make sure it's called 3 times. Would you do like let calls equals 0, calls plus equals expect calls? By the way, you can do to be greater than, but here we just want to do to be like that. That's a pain. No one wants to do that. So a just mock or just fn, oops, typo, ha. Just fn returns a spy or mock function, and that mock function is a function in every sense of the word. It can be called. You can pass any arguments to it, but it also remembers all the things it's been called with. So in this test here, to have been called times, we see that spy was called twice. So this thing passes, but if we call it 3 times, and we dot only this test, so no others. Oh no, this should be a test file. There we go. And we run it, so only this test runs. We see that Jest can give us a really nice output that, hey, you meant to call this twice, but it was actually 3 times or vice versa. Cool, and they can do more than that. Get rid of that focus there. Because they keep track of what they've been called with, you can expect that they've been called with a certain thing, or you can use the value matches from before, like expect.string containing, which is kind of useful. You can also do implementation mocks, where you might say that like this spy function always runs this function, which is kind of like saying const spy equals name is Josh, but this thing also remembers what it was implemented with. And you can have those be used in a configurable amount of times. Like you might resolve first to one value and then the rest of the times a bunch of other values. Or like you might mock implementation once to succeed a first time and then throw an error to make sure that no other times it's called. So these are pretty configurable. Pretty useful. I unfortunately did not include any React specific content in the slides, but I will say probably the most common thing I use just.fn for is click listeners in my React components. I can't tell you how many times I've written a test like expect onClick to have been called after some button or whatever was clicked. So that's a really common use case that you might use these for in your React component. Any questions or comments on mocks? Cool. Now for my least favorite part of Jest, module mocks. So this gets a little complicated, and I found it to be hard to understand at first. So let's say that you have a really complicated setup, or like let's say you have files that import from each other. Let's say you have a producer file and a consumer file, whatever. The consumer file takes in from the producer, and the producer does something that you can't easily rely on during tests. Maybe it calls to an external API, or it creates a random number. And Yeah, testing randomization stuff in unit test is really hard because you want your tests to be nice and deterministic and easy to understand. And then math.random really just fucks that up for you. So this consumer thing could be really difficult to test if we weren't able to swap out producer. Fortunately, Jest has a thing for that. What you can do is you can .mock a module. Let's open these up side by side. Following screen. So when we do just.mock producer, we pass it a function that is used instead of the producer.js file. So instead of producer.js exporting a function producer, instead it returns an object containing producer, which is a function that returns 0.5. And in this way, we can ensure that always when we run producer in this consumer test, it returns the same thing. Oops. So if we run this, we'll see that these tests pass, and these tests always pass. There's no math.random being called. In fact, if we were to throw new error, nope, that's close enough. In this producer file, I don't even think the file gets run at all. It's just completely ignored by Jest, and instead we use the mock equivalent. So that's useful if you have a file, you can't stub out or mock the file's contents, but you need something that relies on that file. Any questions or comments on that?
Out of curiosity, how often do you do that at your job at Code Academy?
More than I want, honestly. It's pretty common in React testing, which I really hate. I don't like this that much because I find it's really hard to keep track of. Like, let's say that consumer is switched to like doing, I don't know, like its own thing and like stops relying on producer. Like, there's nothing in your tests that stops you from like, oh, I guess now it's failing, but like, there's nothing that stops you from just leaving this in forever. I find it kind of loose and hand wavy. It doesn't play well with TypeScript either. Because like, there's nothing stopping me from like YOLOing the name of the thing, and then like TypeScript won't know what's wrong. Like, that's just not a thing. That being said, it is somewhat common for React components if you can't stub them out. Like, if you're working on a component that sets up Google reCAPTCHA or like some other really complicated external thing, and you don't want to have to rely on that external service, there's no other good way to stop the native thing from being used. So like, I'll show you a test I wrote now, actually. Like in the real world, we're setting up our email verification page where you can say, yes, this is my email, to use tests, or to use Google reCAPTCHA. reCAPTCHA. Where is it? I used the wrong branch, didn't I? Guard test.tsx. Look at all those tests we have. I should feel really good about ourselves. So like here in this test, ignore the fact that like half of this syntax makes no sense. But like, I had to mock out the React Google reCAPTCHA v3 component because I needed 2 of its components. So I mocked out the module. So like, it does happen and it's unfortunate. And I think in like 5 to 10 years, someone will figure out a better way of doing things. But until then, that's just what we're stuck with. Does that long-winded explanation answer your question?
Yeah, it does. Thanks. It's interesting.
Super. I'll just put these all next to each other. You don't have to figure out what all this stuff is doing. This is like some internal library crap. Any questions or comments further on module mocks? Cool. And as with everything in Jest, it is gloriously documented, although I think not as well documented as some of the other stuff on their website. That URL. I think it's useful to understand how it works on the inside because people tend to mess them up a lot and then get confused because it is legitimately confusing. So like, let's say that you're looking at half consumer, which is this file that calls and checks the result of the producer against 0.5. Let's say that you wanted to make sure that like in each test, you can specify what the producer returns. Like now you actually care what the producer returns. Before we didn't. When you do a mock, like a just.mock, this code, this mocking of the producer, would need to happen before the import of the file that uses that mocked module, which kind of makes sense. First, we need to declare this is how the module behaves, and then we can run the code that imports the module. So like if we were doing this, let's say, which is roughly equivalent, this code here wouldn't make sense. First we import from producer and then we define how producer works. We would have already run the producer file by the time the mock happens. So what Jest does is something called hoisting, which you might have heard of from functions before. It'll hoist this just.mock code before any of your import statements for you behind the scenes magically, which means this .mock will run first before the imports. And because it runs first before the imports, it works. This will happen, and then the import will use the new stuff. But if you want to use any mock variable here, well, you need to make sure that that mock variable also gets hoisted with the just.mock. And the way Jest knows whether to mock your variable is one of the stupidest, most funny things I've ever seen in modern testing. If the variable name begins with letters M-O-C-K, it gets hoisted. That's all Jest uses to know. It's some BS. I don't like it. It's annoying because like sometimes you want your code to rely on a library like React, and React starts with R-E-A-C-T, so it doesn't work. But it's a whole thing. Does that make sense and seem as kind of arbitrary and silly to you as it does to me? Cool. And just to confirm, this file works. This does exactly what we want it to, because our mock produced and our just.mock both get hoisted to above the import statement for us. Oops, I ran the wrong command again. Just have consumer watch. So like these things run first and then we import from have consumer. Cool. So that's all I have slides for on like the actual syntax of the tests. It's all the very fun foundational building block stuff. But I'm sure you all have questions on things you wanted to see other than that or just wanted to go over. So what else would you like to talk about before we talk about good testing strategies?
I feel like it's really difficult to know like where to start. Like what do I test? And so I guess my question is like, do you have like some kind of structure for how you approach like starting to test?
It's a great question. I think I should take a step back from what I'm suggesting you do and go over other things and just go through the slides, because I do actually, the next slides are an answer to that question and similar ones. But thank you, that's an excellent segue for me. There are two strategies that I like to take that help answer that. One is AAA, not the auto thing, but arrange act assert. So when I'm writing tests or deciding to write tests and what to write for a thing, I want to figure out what the pieces of logic in the thing are. So in my mind, and what a lot of people say, is that a good unit test has a couple of attributes, among other things. To start, you should be able to name very simply what the unit test tests. By the way, I realize this isn't a direct answer to that question, but I promise you it's in the next slide or two. So like if your test name, as we saw before, is like if works, that's not useful. And that doesn't explain what the test is. But in these tests, we see names like does X when Y, which I think is a really good way, if you can make all your tests have a name like that, to force yourself to be testing exactly one piece of logic. You don't want to do like this in a test where you have first one setup and then the act and then some assertion, and then you do another thing. Because if you have multiple groups of expects in a test, let's say that you're running two of them, if the first one fails, all the other ones will never be run in the first place, because an expect failing is throwing an error. So it's good to have individual granular unit tests where each one tests a specific thing. Sometimes it's impossible to get like exactly one expect. You like really need to check like two functions being called the right way or something, and that's fine. So it's really one idea, one output of the function you want to test in each unit test. I'll also say that that lends really well to AAA, or range act assert, where just really hammering in what I think is a good test suite versus not. AAA is arrange act assert. In some projects of mine, especially like open source ones, I will explicitly write in my tests arrange, act, and assert as comments. You really don't need to do that. That's That's probably overkill. But at the very least, I think it's a good idea to have blank lines between the groups just to signify to the reader what is what. So like this test is, what is this, what's 6 times 3? Like less than a third of the length of this test suite. But like this, it's not very informative. It works, doesn't tell us anything. I don't know what like the expectations are. So this is a much more clear, understandable unit test. So AAA, yay AAA, a forcing function to have good tests. Then lastly, what do we test? This is specific to React, but I think it holds true for a lot of things, not just React. Try to test just the logical behavior. Try to match yourself up to those AAA style titles. Renders X when Y is true. Does not render X when Y is false. If something is clicked, this mock expect to be called with. So if I'm looking at a function, let's say I'm looking at the greet function. Oops. Greet.js. The exercise I might do is I might try to find all the logical checks in this function, all the if statements or whiles or ternaries in this case. And then for each logical branch where it could go one way or another, that's 2 tests you might want to write. In this case, greet might have 2 tests. One where if there is a third parameter, making sure it renders this result. I'll just split this across lines for readability. And then the other test might be if there's not a third parameter that does this result. So to actually answer your question now, I'd recommend try to go through your component in order and see those AAA test names as you go through the logic. For each branch, what are the 2 AAA checks? Does X when Y? Does X when not Y? That you can write in your tests. Does that make sense and start to answer the question? Cool. One more thing specific to React components. I've seen a lot of tests like this. Oops. Excuse me. Or like test my component, whatever, where they're like just like it renders a title on wrapper equals mounts, whatever, and then like they'll make sure that part of my syntax highlighted. I don't think this is a particularly valuable unit test. A lot of people will write tests on React components on the stuff to make sure that like specific things in it exist, but there's no logic under test there. You're not checking that the H1 exists only if some condition is there. And then I found that these types of tests, the ones that just check the output, really only fail when the thing is intentionally updated, which kind of defeats the purpose of the unit test. It's kind of annoying. So 2 strategies you might take there. One is you might switch to a snapshot test if it's just really important to you that the thing always has the exact same output, which is true for some cases. Or you might just do an it renders test, where you just do this, and you just want to make sure there's no logic in this component, but I just want to make sure it doesn't like blow up. Just confirming I can unit test it in the future. And actually, I think I forgot to write that in the slide. Cool. Any other questions or comments on AAA and what to test for? Cool. So let's go through a function. Let's look at, what's a good function to go through? Let's look at Fibonacci. I'm going to do that annoying call response thing when someone has to answer me. What's a first AAA kind of test piece of logic you might find when scanning through this function? Or in other words, what's a piece of logic in this function you might want to create a AAA test for?
Well, for me, I guess the first thing I was looking at is like the if I is less than or equal to 1, return I. So test if test basically if I is like less than or equal to 1, it returns what you expect, or if not, it returns something else.
Perfect. Yes. Thank you. Very good. Made me happy. Thank you for answering. But yeah, no, that's a very good thing. That's the right answer. It's the first if statement. If there's an if statement, there's almost certainly the ability to test that if statement. Cool. And you can actually see, I don't know how many of you were cheating or thinking of cheating, but this test is kind of funky because it's really just a bunch of cases that we wanted to make sure. And then the last thing, sometimes it can be hard to figure out how to test something. For example, in this cache, like how do you check that something is cached? The cache isn't exported. I find it would be weird to be exporting this cache because it's an internal detail of the thing that's not really the end behavior of it. So you might want to try to figure out, instead of testing these internal implementation details, like a cache or whatnot, can you test what those are supposed to fix for? And in this case, yes. If we weren't using a cache, Fibonacci of 50 would be an extremely expensive operation because we do Fibonacci of 49 and 48, each of which would cause a Fibonacci of the number below them. So we have like an exponentially increasing amount of Fibonacci calls. So this test makes sure that the thing doesn't explode your computer. And that brings up a general purpose point that you don't want to test implementation details. Implementation details are things that matter only to the internals of the component. For example, this cache here, you don't want to export the cache because only the component uses it. It's not part of the public API. No one is going to be passing in a cache or asking this function, hey, what do you have in your cache? They don't care. They just care about the inputs and outputs of the function. So if you're finding yourself reaching into something like exporting a function only to use it in tests, take a step back and think, can I test the function's inputs and outputs instead to really simulate how someone is using the thing? Another example of an internal API people tend to test would be React class states, where like people in Enzyme, I don't know if you've used Enzyme before, will use like component.state to get the state of the component, but that's not how a consumer, that's not how the user uses that component. What you should really do is be like finding an element and simulating it on click or making a network call or whatever. That's the real juice of the components. Any questions or comments on that stuff? Cool. One last section, TDD. Have any of you heard of TDD before? Have you had like oh my God, did they already go over this stuff? I don't know who they is. Have any of you used TDD? You've TDD'd. Oh my God. Well, then you don't need this. But yeah, I love TDD. I don't use it as much as I wish I did. It's really good for getting good test coverage because you're writing the test to begin with, and it makes sure your tests, your components can be testable. So yeah, I don't know. What have your experiences been? Everyone who was nodding their head when you said you tried it. How did you like using TDD to develop?
I haven't used it very much, but I have before. But my problem with TDD is like, it's kind of like figuring out like in the beginning what your function is going to be returning. Sometimes you might not know what the full logic that's going to be in that function is, so it can be like kind of difficult to kind of just like have it all mapped out in the beginning. But it kind of forces you to make your functions more deterministic, like you said, if you can't see everything that you're supposed to be doing with that function in the beginning. So
Definitely agree. I think there's a misconception in programming that someone should always know what they're doing and like have a complete vision of how things are supposed to be, which is like totally inappropriate and impossible to do. And like TDDs sometimes can feel like it assumes that, or like, oh, you just know how your things work, so you can test them first. And yeah, I think for me, when I don't TDD, it's often perhaps a majority of the time because I want to get that exploration. I want to write the thing and see how it feels and does this even work in the first place. So yeah, I agree. Not always appropriate. Who else has thoughts?
Oh, for me, when I was doing this, I actually wrote out the like methods, and then I tested those methods regardless whether like they worked or not, and then do the test when I figured out which one didn't work the way I expected. I went ahead and fixed that. And primarily I did this for the back end. So when I like have everything figured out and all like ready to go in the back end methods, it makes it really smooth to move on to the front end. Yeah, that was it for me.
I like it, the hybrid approach. Yeah. I think that I agree. There's another misconception that if you're going to do something, you have to go full throttle 100%. You couldn't possibly have any divergence of opinion from the pure form. And yeah, like you don't have to do TDD completely from start, completely write your tests and then start your stuff. I think it makes a lot of sense to start them, to get them where you want to be somewhat, and then to use tests to help understand how they work. Personally, that's how I normally do my tests. I like get the functions mostly working or whatever I'm writing, and then I'll do tests at the end to help myself like iron out all those edge cases or like help debug them.
So if you're like in React, when you're creating a component and you're adding, let's say you already have a test written for it and you decide that you want to add like, I don't know, another function or something else to render, do you add it to the test first and then add it to, like get that to pass and then add it to the component?
Good question. Oh, by the way, thanks both of you for answering. Much appreciated. I think it depends. If I have a good, clear understanding of what needs to be done, if it's just like, oh, we should have a button when some prop is true, like something very basic like that, then yeah, I'll probably, if I'm in a good mood and like feeling up to it, I'll try to TBD. But to be honest, I'm kind of lazy and I kind of forget about this most of the time. So most of the time, I'll just write the function and then hopefully remember to write the test. I'm not saying that's how it should be. That's just how I tend to do it. Is that what you like wanted to get an answer towards?
Yeah, no, I really appreciate the honesty because that's kind of like how it's been going for me right now.
I think it's important to be honest that like TDD is good, but it's hard. It can be hard. It's good to practice it though. Like that's why I try to do it even if I don't need to. Like it's good to practice these types of things for when they are actually super useful.
On TDD, is that why I guess a lot of startups don't really have good testing or testing at all because of the?
Yeah, I would argue a startup is a fine place to do TDD because it's like a new project from scratch half the time. But yeah, startups are normally chaotic. Sorry, I don't want to say that. That's incorrect. That's an overgeneralization. Startups are often less structured or have less of an understanding of where they need to be. So for them, the equation of how much testing they want is skewed less towards more having a lot of tests. And that's not a dig. That actually makes total sense. If you're a startup, you haven't gotten any funding yet, you're just like some randos, and I guess now it'd be a virtual garage or whatever. And you don't know, like, is this idea going to be good? Do we want, like who do we want using the product? What's our target demo, graphic, whatever? Maybe you don't want like 100% complete total unit test coverage with like completely comprehensive unit tests and end-to-end tests and all this. Like that would just be a waste of time if you're like, oh, this sucks, we don't want to do it. So yeah, a lot of startups intentionally and correctly choose not to have a lot of tests until they really understand where the product needs to be. That's a good example of technical debt being a good thing, where you know you're not writing unit tests and eventually it's going to come back to haunt you. But for now, it's much better to not write them. Shocking, I know technical debt can be a good thing. Does that answer the question you meant to ask?
Yeah, it does. Thanks. That was just interesting because I had a friend who worked at a startup and he was telling me about some of those problems he was having. Yeah.
Definitely a good question. Thanks for asking it. Yeah, I've never been at a place that had like good, like really, really good unit test coverage. It's so rare. And one place at Microsoft, we started rewriting the product, but because we were rewriting an existing product and we already knew what it was supposed to look like, we felt much more comfortable writing extremely high unit test coverage. We actually had 100% unit test coverage, which is something Just can calculate for you. Or if you do just dash dash coverage, it'll take a little bit longer to run, but it'll give you this like really nifty coverage report. I don't know, have any of you used coverage reporting tools before or heard of this? Oh man. So how do you know whether your test is good? How do you know whether your tests are actually covering what they're supposed to? So like I actually wrote really good tests. I'm like kind of shocked at how high my percentage is. But like using just dash dash coverage, we see that 88.89% of all the statements in my code are hit. So like 100% of the functions are hit, but like some of the stuff in those functions might not be hit. Like looking at, what is this? Get integers, line 3. Oh yeah, this was the to-do test. Fine. So like the way coverage works is Jest will behind the scenes make a version of your file where every other line goes like mark line covered, whatever it is, whatever the line number is. And then in the coverage reporter, it'll when it runs tests, receive these reports of which lines are covered. And then if you look at the coverage report in the coverage folder, where is it? There it is. You can get this like absurdly high quality table showing you exactly where your stuff is or isn't tested, which I think this is beautiful. This is like really, really fun. And a lot of people over-index on this. A lot of people will be like, we need 100% coverage. And that's most of the time not a good idea. Like sometimes it's just really hard to get and people get diminishing returns. But if your unit test coverage is like 10 or 20%, you probably don't have enough unit tests. It's a balance. Depends on the team, code type, stuff like that. Thoughts?
Does that measure for like other types of testing as well, or just specifically like unit test coverage?
Oh, good question. I wish it tested like covered for other tests. So like there's in your code, there will be some code paths, some parts of it that are a lot easier to cover in, let's say, an integration test or an end-to-end test. And it'd be really nice if you could get coverage reports from all 2 or 3 or however many you write and like merge them together into one. Unfortunately, I've never seen such a thing implemented successfully. For integration and end-to-end tests, you would have to instrument the entire app. That's what it's called when they add those little comments, instrumentation. And I just like never seen a tool to do that and then run an end-to-end test. If you want to write one, by the way, let me know. I'll help. That would be awesome.
Thanks.
There was this gem in Rails that does like this code coverage and also tests for like code smells. Like I forget what it's called, but yeah, it's interesting.
Is it related to Rubocop?
No, I think it's a different gem. It's like I think called Rails Skunk or something. I don't know.
That's an awesome name. Rails. This is actually really professionally useful for me. Skunk score. Yeah, so there are a lot of tools that like to some better than others. Thank you. I'm bookmarking this. This is professionally useful for me this session. There are a lot of tools that like try to statically determine problems in code of different forms. Like one of my favorite things is ESLint, the little "you forgot to delete this variable that's unused" complainer. Yeah, this is cool. We use Rubocop at work, but this looks good too. Yeah, so things like code complexity, code smells, code coverage, that's definitely stuff that like if you know your app is going to live longer than like 2 weeks or whatever, if you're not extremely early stage startup and you have multiple people working on it, it's a really good idea to set this stuff up. Boop. One last thing I wouldn't mind showing you. I don't know, I forgot to set up ahead of time, apologies. But have any of you used debugging in VS Code? Sweet. Let's say just I don't know if I'm going to be able to. Anyway, in VS Code, there's a way to put breakpoints in your test file and then run that test file. Is this installing? Damn, I don't think I have enough time to really. Oh wait, I do have time to. Yes. So there are a lot of different extensions you can use in VS Code. One of them is the Jest extension. You see this little checkbox here? It's like kind of small and hard to see. it should be that as I write this file and hit save, the file will rerun, and then eventually this checkbox will turn to an X. In my experience, that doesn't really work that well. Notice how it's still a checkbox. But in theory, this Jest extension should work for you. I think my computer is just like overloaded with all the Docker images I have for work. Haha, there we go. And then this extension should be able to show you, like, as a little like red squiggly complaints that like things are wrong. So that's like a nice way of developing, which I'd recommend trying out if you have time. Another thing that should be fun, I don't know why it's not launching, is you should be able to hit breakpoints in code. I guess I'll show you in Codecademy code. Wow, my computer is shitting itself. I don't know what's happening. It's the stupid Jest extension. It always messes with my VS Code. It's incredibly annoying. There we go. So yeah, have any of you used a browser debugger, like in the DevTools? Okay, have you like put breakpoints and stepped through code to see that type of stuff? Awesome, you can do that in Jest too. There's a standard protocol for this. So if I were to go to some test file here, and let's, do y'all use mount, like Enzyme or RTL for your tests? Your React tests? Or neither?
Enzyme. Like enzyme.
Enzyme?
Yeah.
Super, thank you. Let's look at an enzyme test. This is an example of a test that I think is a little silly. So let's debug through it. So like in theory, when I launch this debugger in this little debug section of VS Code, and I do just current file, in theory, it should eventually hit this breakpoint that I put. I really hope it works. It'd be so embarrassing if it doesn't. You know, I think I have the Jest extension installed still somehow. Oh, I have to reload. Let me do that. So slow. Like in theory, I should be able to show you this thing running. If you have questions to ask, now would be a good time as I like struggle to get this stuff set up for the demo. Come on, VS Code. So you can tell VS Code is in debug mode because it's orange, and you can tell that it's ready to hit a file when those breakpoints go from this hollow unbound circle, meaning I haven't yet read in this file and figured out how it's supposed to be debugged, to red. Come on. All right, Jest is running. Progress. Well, this sucks. Yeah, I'm going to give up on this. Any other questions or comments while we still have time?
Are there like any pros or cons to using like a library that's a test runner and a session library, or just or using libraries that are like separate things?
Oh,
A test
man.
runner and the one's in a session library.
I'm such a big fan of that question. Also, look, my breakpoint's attached just in time to interrupt your question. I'll answer yours. Yes, that's a great question. Personally, I agree with the implication there. I wish Jest was its own thing, and then the assertions were its own thing, and then the mocks were their own thing. I find it annoying that it's all bundled into one. There was another popular library that came before Jest called Mocha, which did not bundle in the assertions with it. Have you all used Mocha before? Okay, yeah, there you go. I like the Mocha Chai model, to be honest. I like being able to put them separately. But it is kind of convenient, especially in like new like applications, to not have to just like choose all the different packages. Like if you use Jest, you're using the Just expect. Like why would you use something else? So it is kind of convenient. Yeah, in theory, I wish they were different. Do you also wish they were separate in theory?
It's I find it like it's more confusing that when everything's combined, where like trying to decide like what, or trying to find what you still need from like other libraries but with they're separated, you kind of know what you're getting.
Yeah. Yeah, agreed. Pros and cons. By the way, now that my breakpoint has been hit, I can show you the thing you already know how to do in a browser, but in VS Code now. Where just as in a browser, you have your call stack, your local variables, and then you can run code in your debug console. Let's see if this works. So like, if this assertion would change to fail, you could like see the errors in your console. So yay, this is like a key, very important part of how I write unit tests, where if I can't get something to work, I'll put a breakpoint in there and try to figure out like what the hell is going on. This one's pretty simple. So that there's not like a huge amount of like mock functions or mock modules being thrown around or whatever. But it is really nice to be able to like look at all the variables and see where in the call stack you are, personally, I think. You can do like rendered exporter dot find button to see if it has any buttons. First dot, what's it, simulate click. Does that work? Yay, it worked. Cool. Debugging. Any other questions or comments? Cool. Well, it was really nice seeing you all again. I guess I'll see you tomorrow. Let me know, or I guess let Dana know if you have any questions for tomorrow's workshop, which is about performance debugging through a web app, which is something I have actually been working on at work. So I'm really excited to show you. What I'm going to do is I'm going to update the slides to include some of the stuff we talked about, like React testing, debugging, coverage, because I'll admit I wrote most of them last night. I'm not good at keeping track of time. And then definitely let me know, connect on LinkedIn if you want, as one of you already did, if you have any other questions on like testing, right, TypeScript or other stuff. Thanks. Bye.